It's Dr. J and we're back, and today we're talking about the mole. So the mole is the amount of material containing 6.02 times 10 to the 23rd particles. All right, 23, 23rd, 23, it doesn't matter. Shout out to LeBron James and Michael Jordan. What does this mean? All right, so I like to refer to as a mole as, think of it as the chemist's dozen. So get ready, everybody. You're about to hear the word mole a lot. Okay, so this is one of the key things you want to understand. A mole is critical, basically going forward. All right, so you want to understand this mole. So once again, the mole is the amount of material containing 6.02 times 10 to the 23 particles. All right, so basically 1 mole equals 6.02 times 10 to the 23, right? So if we think about dozen, right, because this is why they call it a dozen, because it's always going to equal the same thing. 1 mole equals this amount. So when we think about dozen, like a dozen eggs, when y'all hear me say a dozen, we know that we're talking about 12 eggs, all right? That's a dozen, okay? So whenever you hear me talk about a mole, for instance, 1 mole, then I'm talking about 6.02 times 10 to the 23 particles, okay? And in this case, it could be really anything. If I'm talking about, 1 mole of basketballs, that means I have 6.022 times 10 to the 23 basketballs. If you hear me talking about I got 1 mole of bananas, I got a whole bunch of bananas, right? A mole is a lot. It's this huge, big number, okay? Now, specifically, the person that came up with this was Avogradro. That 1 mole equals to this number here is Avogadro's number, okay? So it's always going to be the same, all right? 1 mole equals this big old number. How exactly did they come up with this? Basically, to sum this up quickly, the mole is basically equal to the number of atoms in a element. We did this with a couple of different elements, okay? So we go down here to carbon. Like I mentioned, 12 grams of carbon is 1 mole. And because 12 grams of carbon is 1 mole, then that means that 1 mole has this particular amount of atoms always, right? Because 1 mole equals 6.022 times 10 to the 23. But we also, right, you can do this with aluminum, okay? So 26.98 grams of aluminum is 1 mole. And we understand that 1 mole is equal to 6.022 times 10 to the 23 aluminum atoms, okay? So let's talk about this, because now we're going to dive into this relationship here, okay? So this is going to show a relationship between our mass and our number of atoms for an element. And this relationship we call molar mass. Okay, so molar mass is basically the mass of 1 mole of atoms of an element. Once again, molar mass is the mass of 1 mole of atoms of an element. So we look down here, right? If we compare these different elements, aluminum, carbon, and helium. Let's say that we got 1 mole of them all, right? I got 1 mole of aluminum, 1 mole of carbon, 1 mole of helium. I understand, right, thanks to Avogadro's number, that 1 mole equals 6.022 times 10 to the 23, whatever. In this case, they're aluminum atoms, okay? So we need to understand when we're talking about moles, right, they all are going to have the same amount of atoms. Now, the difference between all 3 of these is, well, they're different elements, right? This is aluminum, carbon, and helium, but they're all 1 mole. So how is that going to impact when it comes to our mass? This is where molar mass comes into play, right? The mass of 1 mole of atoms of that element. So 1 mole of aluminum is 26.98 grams of aluminum. And then guess where we see this number at? The atomic mass number, right? We can see this on the periodic table. Same thing with carbon. 12 grams of carbon, right, is a mass of 1 mole carbon. And then if we look at helium, once again, we look on our periodic table, 4 grams of helium equals to 1 mole of helium. Okay. Now, the key thing we want to understand, right, with this mass is that, well, if it's 1 mole, right, and they got the same amount of moles, they're all one, and then they have the same amount of atoms, why are their masses different? Because they're different elements. Notice the size of these elements here, right, these atoms. Helium, very small, right? Since it's very small, we're going to see a smaller mass. Carbon's a little bigger, we see a bigger mass. Aluminum, right, bigger atom, we're going to see a bigger mass, right? And we see this as we go across the periodic table, okay? So we want to understand a couple different things here to sum this up. A mole is 1 mole equals 6.022 times 10 to the 23. Once again, we call this Avogadro's number. But then we also have to understand with the mole is that we have molar mass, which is the mass of 1 mole of atoms of an element, okay? And basically, a quick cheat code for molar mass, you can always find the molar mass of your element on the periodic table, all right? It's the mass of that element. That's all it is.